The next thing we're going to have to calculate is the length of the stringer. To get the length of the stringer, look at this diagram and think of the lengths in here that will make up a right angled triangle. Those two yellow lengths initially appear to be the two that you would use. That yellow length is the going of the flight. That yellow length is the rise of the flight. However, if we use these in a triangle and do the Pythagoras calculation, we don't get enough timber. Let's see why. If I solve the right angle triangle with going of flight and rise of flight, I'd get that yellow distance. But we can see that's not enough timber. I'm short at the toe and I'm short here for the horn of the stringer. So what do we need? We need a larger right angle triangle. We need to use the orange triangle in our Pythagoras calculation. That side of the orange triangle is the rise of flight. But this side is the going of flight plus this distance. How much is that distance? That distance is the going of step. So to do the calculation, we need a formula that looks like this. The length of the stringer equals the square root of rise of flight squared plus going of flight plus going of step squared. To use the formula, we've obviously got to have the right figures for the rise of flight, going of flight, and going of step. But you also have to get the brackets right inside the square root. Rise of flight squared. This part has to be bracketed with the square root sign outside. So in this exercise, to find the length of the stringer, we've got a going of flight that we've just calculated at 2030, and our going of step is 290. If we put those figures into the formula, we'll get the length of our stringer. Our rise of flight, 1.440. Our going of flight, 2030. I like to work in metres, but you'll obviously get the same answer if you work in millimetres. If I put that through the calculator, I get I need order lengths. So to order this, I'd go up to the next 0.3 increment. So I'd order two at 3 metres.